All right, so this is in the center of a gigantic tendon. I know, in tendinenthesis, she's, oh, Roger, that's crazy. No, it isn't. This is exactly what happens inside of these tendinenthesis. They have all these little white fibers going in, and this just happens to be very big. I have one here that's very small, and it still has all the fill in between here. For some reason, all that washed out and left all the fibers. All right, these tendon balls come down in bundles, not just one. They come down in, there's going to be a whole batch more of these somewhere in this area, because when they come down, they don't come down one at a time. This is what it looks like. And when they grow, you got the tendon, you got the insertion point, and that's the anthesis here. And as they fill in with crystals, you got there, minerals fill in there. And then they will break right there and snap right off. But the fibers running down to these crystals are just like this one. I show this a lot. That ball is this ball right here. And it went down into, right up to that layer right there, into the flesh, and was stuck in there, in this ball. So the ball was just like this. And that's how the tendon could pull on it. Now, you see all those little white dots? Those are basically these. And they come down to the end. Now, this would have had another tendon sitting right on top of it. It would have reached out a little further and had a ball on it. And they'd slide back and forth on each other. Whoops. So I think that was part of a ponerosis tendon. This, I don't know where that was in the body, where this one is in the body, but it was in the body of some creature, huge, gigantic creature. You see all that? Isn't that something? Look at that. These are people walking around in here. That right there is the roof, basically, of that tendon anthesis. And these are all the fibers in it that give it strength. And either they were replaced by the selenite or they were the selenite. I don't know. I really don't know. I do know that they are there right now, and that as far as I'm concerned, this is where they originated, in something virtually identical to that. This is what it is. And that was the top, and they were crawling around on those things. I claim everything there is biology. I don't care how you cut it. Now this is, I showed you the heart, I showed you the transition metals. Look at this. This is a clamshell. And it's an opal. It's either a clamshell or it's a guy's ear. Now, I got this one here. This is a clamshell. There's no question about this. All right, and I believe this is basically identical to that. Well, why all these colors? And why just splattered everywhere? It's like somebody splattered them everywhere. Well, the reason is, inside of all biology, there is a whole batch of different types of minerals in here. Very tiny amounts. But in the right conditions, in the right chemistry, and the pH, and the right transition metals, which is blood, and in this heavy silicates, which is a very reactive molecule, atom, and in salty silicates for long durations of time, the nucleophilic invasion would come in, and first thing it does is one of these colors grabs a hold of a guy over here, and he says, hey, me and you, we work together, we're blue. Now, if another guy comes that's like me, and another one comes that's like you, let's just get them over here and we'll just hang out together. That's called flocculation, flocculating. They flock together. I'm serious, that's the name of it. So a blue one came over here, a blue one came over here, one over here, one over here, one, and they started to grab their buddies to come. And these are all other ones that are floating around. Some of these yellows will end up attaching to here. Now it's stabilized. Pretty much everything in there now, I would assume, is stable. But I can't discount the fact that in another 100,000 years, the whole thing could be blue. Because there's still going to be some kind of movement through there. Ions nibble in because they have charges. So I can't discount the fact that this would change. In other words, it's not 100% certain that that will never change its enormously gorgeous state of these colors. They could add and change and turn one complete color according to nucleophilic substitution and invasion in long half-life situations. Okay, my outstanding friends, I claim everything is biological. So I was asked about selenite. How could this be considered biological? I mean, see right through it. It is biological. Now, I have some more here. This was sent to me years and years ago, it seems like forever ago, by Becky Dorius. I believe that's her name. Like I say, it goes back years and years. And Becky, thank you. And this is biological in origin, and I will show you. And it goes by the name of selenite or gypsum. Gypsum is more of a fractured up little scrappy looking stuff. Selenite is a very clear, transparent, and then there's a middle of the road one which they call satin. It's all the same chemical composition, and we're going to look at the chemistry, because that's the key to everything is chemistry. You got to have the chemistry, and they do not understand the enzymes and how quickly they work with biology, and especially in the conditions of the Great Flood, which was boiling hot biology, extreme electrical currents from the discharges of this impacting body, and the whole ball of wax caused these mud fossils. Now, there's going to be certain areas that in direct zone of impact which were going to be extremely changed, and then there's going to be other places that just boiled and cooked and just settled, but the whole world was one giant flood. And that is the kind of chemistry, and I'm going to explain to you exactly how this happens. And it happens with half-lives. And this they don't understand. It's ionization. And the reason they don't understand it because they don't understand dipole electron flood theory, which replaces the standard model and fills in all the gaps of the periodic table. Hydrogen is not one proton. It's 1,840 or so dipole electrons. I'm going to show you this in my theory. Very, very simple. Simple. You pick this up in 10 minutes. I am not kidding you. It's just like little bar magnets back to back together, but when they start to form bigger than light and electricity, they turn into a ball, and all the plus charge goes to the center and all the negative charge goes to the outside. Not too far off from the standard model, but extremely off when you take in the particle interactions, which hydrogen, instead of one interacting with everything else, it's 1,840 particles interacting with everything else. Helium, which they say is 2, but they have 2 neutrons added to it, so let's go with 4. That's in my world almost 8,000, 750 something. No, 7,000 something. Anyway, it's 4 times about 2,000. So it's 7,500. Some I figured it out. But once you start getting up into here, you're just in hundreds of thousands. And they can mix and mingle in such elegant ways. And only thing they can mix them and mingle them in those specific, fabulously exotic ways is an enzyme. And they can work 2 billion years worth of chemistry in less than 1 second. I'm telling you, that's what they claim. And it's click chemistry, which means the enzyme comes over and goes, done, which would have taken 2 billion years. And then it goes on to the next one. Bing, boom, 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 boom. They split up particles. They just break them all up so we can break them into their component pieces. That's what an enzyme does. You don't have them, can't break them up. All right, let's get into this, because this is how selenite forms, is because of enzymes. All the mud fossils are a product of this great flood, the boiling, having all of the enzymes and fluids from bodies mixing together, blood and the whole 9 yards, finding stability through the membranes, which coat everything and make organs appear just completely by themselves. And that's flat because it was died in a great flood, and this organ is virtually transplantable. The blood coming out there, I had it tested, and it's human. And this was from the Great Flood, which they claim, the academics, that was only slimy creatures were alive at this time, which is just not true. I have the evidence to show. These are bones. I have body parts that have been tested, DNA tested, and they do not conform to what academia would like to hear. And I'm sorry, truth is truth. All right, this is as simple as it gets. Right now, they have a hydrogen atom, which is the smallest atom that exists, way down here, the tiniest one, which is stable for the most part. And they claim there's one big positive core, which is the nucleus, and the electron sits out here. So the proton, which is this big gigantic jobber, sits in the center, and it has one little bitty particle that is the opposite charge, negative. This is positive, and that's it. And you can smash this to bits and you get a shower of all kinds of particles. But they think this is one big huge positive and this is one little tiny negative, and they have the same charge. This is equal but opposite charges. That is just incorrect. What they really have is that. So instead of this that can be smashed into a million pieces, it's this which can be smashed into a million pieces, but they're these pieces. They're not just fractured little bits and pieces, which they think they are. They think they are just little chunks of this and that. You see? They think they're taking a neutron, which in my world is 1840 of these little things. And they're hitting it into a proton, which in my world is 1839. Because a proton is not stable. It wants to take another one on to get neutrality, even numbers, or it wants to give one up to get down to neutrality. Regardless, when they hit these together, they just get trash. But what they're getting trash of is this. These go flying every which way. So they're going to get the little bitty particles we're going to see, and I'm going to show you in a minute. They're going to see the photons. They're going to see all these little bits of energy, and they're going to see X particles. X means they're like this, just big globs and who knows what. Chunks. But every one of them is made out of these particles. There is not a single thing that isn't made of these particles. This is the only thing that's made in the universe, is a positive and a negative dipole. They can go their separate ways, as I will show you, but this is the smallest that exists, and these are those smallest that exist. They know this at CERN, but they also see these big jobbers because they're just smashing monstrous particles, and we did not. We started with these right here. Same thing, which is a stable photon. Half of that is what you would call heat. That right there is heat. Half of this, if you had the glowy part, that's electricity, lightning, static, and it has no weight. The other side, the black part, the two of them together make up an electron, a dipole electron. They can be split, as I showed you or will show you, and they sit together just like this. To make up, they have to go side to side, just like that. I'll show you all this stuff. But their original configuration starting like this. We didn't have to do that. We started way down here. So we started way ahead of them. They're just digging through all this stuff for the last 30 years. Literally, I'm not kidding you, more than that. All right, now stick with me on this. It's very simple. I do the mud fossils, which are bones and lungs and hearts and feet and everything else, turn to stone during these conditions. And they did because of membranes, which are these. Phospholipids. There's two layers of phosphorus with lipid fats in between with these ion protein channels. They will only let certain particles in and out, and they know which ones to let in and out, and it's governed by polarity. They're ion channels. Ions means one that has an extra charge or not an extra charge, that type of thing. It's an unequal charge. And that's how they pop back and forth. I'm almost certain of that. So now, this coats every single thing in your entire body. Every cell, every bone, every piece of meat, your skin, it's all this same stuff. Now, during these flood conditions, the membranes, because of their particular structure, did not disintegrate. They allowed things to come in and out. Just like if you boiled a bone or a body part, a leg of a creature or something, it had all the blood and everything in it, and you boiled it in hot, silicate-rich, salty waters for a very long time, it would just, everything inside would sort of leave, and then if you let it dry out again in those same liquids, they would go right back through the membranes again and try to find stability, which is their normal procedure. They go through here and they say, hey, I need some of that stuff, and it drops a few things off here and there as it passes by the membranes. And that's what allows you to feed your cells. Once you die, they don't come in and go back out. They come in and they find somebody to hook up with. And in this case, primarily it turned to mud. And the mudstone is because it's flesh. Flesh is mud. Flesh would turn to mud. If I ground this all up and put water in it, you got mud. Flesh is mud. Mud fossils are fossilized flesh. Mostly. Bones didn't make it. Bones did not make it. Well, actually they did. But the white part didn't. That's the only little white part left in this bone, and that's the onlyest, I say that, that's my little word, that's the onlyest little bit of bone is left that I can find almost in any of my mud fossils. They almost all completely disintegrated the bones or turned them to mudstone or some other part. The other ones turned to all kinds of different things. Some of them turned to opal. It depends on where they were. Even clamshells turned to opal. Eyeballs turned to opal. I'm not kidding you. I have all that stuff I can show you. I don't have all of that stuff here, but most of the stuff, I do have a lot of opal here, but it's just, it's not it's, well, hold on one second, just so I can prove what I'm saying. You see that? That's an eyeball. All right, so you guys holding it's probably about this, it's maybe that big around, just not much bigger or not much smaller, or maybe even the same size as ours, I don't know. But that's clearly the eyeball, and that right there is the strap that makes the eyeball go like this way and that way, and this is the tissue surrounding it. And I see all of these little tiny fibers in there. Those are all going to be nerve connections in that area behind it, or they could be bone. I can't tell for sure, but that's the socket in this area, and that's clearly opal. Now let me show you a heart. Okay, there is a heart cut across, and these are the chambers. That's the heavy-duty left ventral wall, the aorta and so forth, the plumbing at the top. These are the heartstrings that come down to all of this fibrous stuff, and they do this. One pumps in and one pumps out as it twists, and that's how you circulate your blood through your body. Now, that is a heart. You see the different colors? You see that different wall color? Then this, then that, then this. Let's see if we can find something opal that looks similar. Ooh, look at that. There it is. What is this in here and what is this in here? And why are these little colored things all the same color around, basically? There's a little difference in color here, but that's because of the way it was sitting, and I'll explain that in a minute. These are the ventricle tubes, basically. Probably that's the aorta. That is that wrapping around the outside of the heart. And there'll be a very heavy ventricle wall in here somewhere. Now I have a heart here that is crystal. It's not opal, but it would have been opal had it been in a place where it was saturated with blood, because that's what attaches. These are looking for something with a certain polarity. Now let me show you what blood does, because blood carries virtually all these transition metals. All of them. And this just settled in blood literally forever until they found partners that they were happy with. And that's what half-lives are all about. They keep breaking down until they end up with stability, and that for this is stability. They got to understand the half-lives, and to understand the half-lives, you have to understand dipole electron flood theory. It's really very, very simple, but it's just, you got to start from the beginning, and they got to start to listen. And this, my friends, was cut laying this way because the heavier metals are deep, they go deeper, and the plasma drifts up to the top because it's lighter, it has no metals in it. So that's why I say it was this way. And a little tilted somewhat because the green settled here, but not at the top. All right, so it had to be this way and maybe like laying a little bit to the side, something like that. Because the top has the green everywhere equally. See it? See the green everywhere equally? You see that? See how it's equal around all that whole top of the heart? Over here you got green settled over in this area. Now the green, I'm not sure what that is. I always associate green to being copper. As a matter of fact, hold on a second. I never find anything when I'm looking for. Hold on one second. All right, sorry about the interruptions there. This, I put electricity into this for a little while, just a little battery, just letting it discharge through here. And it was a copper wire. And then you get this green. So the electrical, which is, anyway, I'm not sure what colors were created by what chemistry, but I will show you the chemistry that is involved and the colors. All right, this is very, very simple stuff, so don't freak out. We're talking about chemistry here, and these are the transition metals. And you see what they are? They have all these charges, +3 and this and that, and they're all different colors, different metals. And some metals have several different types of charges and several different colors. And the charges, every different charge has a different color because it's a different impact. It's just like this chart here. It has all these different colors. Same light is hitting it. I'm not changing the light. So what we see is different colors. It's because where the light bounces back, it's a different hardness, basically. It's really, that's the way you want to think about it. This would be like a pillow. And you take a basketball, you throw it at a pillow, it just barely bounces. It boof. And you make a harder and harder pillow. It bounces a little more, and then you make a sort of a hard surface on the pillow, and it bounces pretty good. And then you make it like a brick, and it bounces like crazy. And then you make it like very reactive, and it really bounces back. That is the bounce back. How slow it bounces, faster, 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 faster. And then you get into X-rays, gamma rays after the ultraviolet catastrophe, and all you have left is the dark particles. That's a whole nother conversation. These are what I just showed you, collect and flocculate and adhere to the chemistry that wants them there to stabilize. That's why these opals are here. They stabilized because there was a very long migration period of products through there using half-lives. enzymes use half-lives. This is what I don't think is understood. Well, I know they understand they use the half-life, but I don't think they understand how sophisticated that half-life is. Okay, check this out. This is a huge crystal cavity in the ground somewhere. I believe it's down South America. I'm not exactly sure. This is these crystals, and I believe they're selenite. All right, I don't think this is quartz. I believe it's selenite, which is selenium and oxygen. I think it's selenium dioxide, something like that. Hold on a second. Okay, called away several times, but I believe we were talking about these crystal, or this selenium. And this is a selenium that was from flesh, I believe, and muscle. And this is selenium that is from a tendon. And that is the abrupt transition where the tendon met the muscle primarily, and that is the glue that glues the tendon. And these are all the different layering of the tendon. You see that? And in each one of those layers, there's literally thousands more layers. And this is the bloody goo that stuck that tendon to the muscle. And this is selenite, gypsum, whatever you want to call it. Well, this is a form of gypsum. Gypsum is this molecular formula, basically. Gypsum has the formula, da da da. Now, some of it is clear, like this. Some of it is all crunched up and different, and some of it is like this, only satin looking. I don't think you can see through it like this. So that's the differences in selenite versus gypsum. It's basically the same thing, but there is a selenite ion. See, like I said, some of it can look like just rock. That's gypsum, and some of it is the clear, like this, and it forms very nice crystals and so forth. Now, so enough for that. And this is the chemical formula of ozone, which is an important part of that. And I need to look into this a little deeper, but forget that for now. And this is it right here, photoconductivity. This is the interesting thing about it. And when I say photoconductivity, it doesn't mean you can just look through. It means it creates conductivity. Listen to this. Selenium, non-metal in the group 16 of the periodic table, belong to the oxygen family. It has various allotropic forms and exists in different oxidation states. Selenium's chemistry involves its reactivity. It's reactive, particularly in forming compounds with other elements. It can easily form compounds with other elements and bind to them. Now, its unique properties like photoconductivity with this. And then you can have all kinds of different colors in the middle of it. So it says it plays a crucial role in the various applications, including electronics, glass making, as an essential trace element for some organisms. It's in us. Selenium's in everything. And they're talking about these different colors and reactivity, organoselenium chemistry. It's in us, and I'm not exactly sure what it does, but I believe it works in some of the important half-lives. It's used in photocells, isotopes. This is the important part. 5 stable isotopes. That's a lot. Selenium in biology, essential trace element for many organisms, including us, including humans, where it is part of selenoproteins. Proteins are these enzymes. Are enzymes and proteins basically the same thing? Very, very, very exotic little chemistry. And these are important for that selenoproteins. And they play roles in thyroid hormone metabolism, DNA synthesis, protection from oxidative damage. These are very, very important selenium proteins. But those are enzymes. Now those are constructed, I believe, by bacteria. Bacteria are the things that make the ribosomes. And this particular protein is a ribosome that contains selenoproteins. And I think that's made by a bacteria. And if you don't have the bacteria, you're not going to get that specific protein. And there's probably going to be thousands and thousands of them that use that seleno, substrate. And then they add a little this, a little that to make it to do something else. Oxidative stress damage, DNA synthesis, hormone metabolism. They have like a base unit, and then they have little things they can add on to it. So, by changing a little click here. So in other words, let's say that's the enzyme. And I'm going to tell you right now, if that enzyme is not, if it's even the tiniest bit different, if this green one was changed over to where that red one was instead, and they were backward, it wouldn't work. Or it would be damaged. It would not do its function correctly. Just one little click, and there is literally probably hundreds of thousands of them in some of these long chain polypeptides. But my point being is that this has to be so exactly specific that all you have to do is nibble a little piece over here, and you got a new molecule. Or it doesn't work. Or it works better. So these are very, very specific enzymes. And they are the things that break and make half-lives. And you got 5 different stable well, hold on. Check this out. There's all kinds of things going on here. All these different transition metals are different types of body chemistry. There's some gold in here. There's selenite in here. There's quartz in here. There's cubic, all kinds of things going on in here. Fool's gold, regular gold. This was in, I don't know exactly what the body chemistry was, but I would assume it was probably very close to a heart or a liver. Liver has a lot of these secondary metals in it, in quantity, because it's dealing with this stuff. A lot of metals in your liver. That could be from a liver. Okay, if you took chemistry, atomic physics, any of that stuff, I'd love to have you comment, because we're talking now about the isotopes of selenium. What is an isotope? Let's say you got selenium, and this is the most stable selenium. An isotope just means you're missing a piece or a few pieces, and you can be missing a whole batch of pieces because there's a ton of isotopes, and they don't even have a clue how many there are. So you either have not enough isotopes and you want one to get stable, or you have too many and you want to throw some out, which is radioactivity. One of them sucks them in and one of them throws them out. It's called beta plus and beta minus decay. And we're going to look into, and it's very, very simple. Don't freak out on me. All right, you will understand this, and you'll be one of the first people to do, because it's not understood in physics, because they don't understand dipole electron flood theory. And it's not bragging if it's true, and it's true. All right, I'm going to just make this extremely simple. I know you've all heard of half-lives. It just means that it takes a certain amount of time to decay into the next half-life. And some of them, this one takes 327,000 years for this particular 79 selenium. Other ones, 75, have a half-life of 120 days. 72 has a half-life of 8.4 days. And one of them has not exceeding 38 seconds. Now, what are they talking about half-life? And what does it decay to? All right, let's look at what these are constructed of. Because if you hear the word selenium, you look up on here and you say, okay, selenium, there it is right there. Okay, selenium. It's 34. No, it's not. It's nowhere near 34. They claim all selenium is 34 protons. You see the Z? There we go. Hold on a second. All right, in my world, this 34 is 34 times 1839. All right, every proton is 1839. Every neutron is just a smidge bigger. It's 1840 because it's neutral. All right, so they're saying protons are all the same, and then they add more and more neutrons. No, you have to combine those together. And those are zones of stability that they have seen. But there's hundreds of thousands of intermediary steps in between here. Just in this right here, 63 of these. This selenium 63, instead of just having 63, which is the protons and neutrons together, it's got 63 times 1840. 115,000 instead of 63. And then the next one you add another 1840, and then another 1840. By the time you get down to the bottom, down here, selenium 97, you've got 97 times, whoops, you got 97 times 1840 approximately. 178,000 particles to divide up any way you want. And they do instantaneous half-lives depending upon the enzymes they're exposed to. And what they're doing is they're taking 1 off and 2 off and 3 off and throwing 1 on and 2 and 6 over here. They're doing all that in less than a microsecond. And that's because it takes literally forever for some of these isotopes to work. Literally forever. Hold on. And I'm talking the billions of years of chemistry happens in 1 second. You see this? Pay attention to this. Enzymes, which are, they understand that they're catalysts, but I don't think they understand, well, all right, it's well known that enzymes are catalysts, and they speed up biological reactions using half-lives. They're saying they don't directly influence the half-lives of atoms or molecules in the context of radioactive decay. However, radioactive half-life is a fixed property, isotopes unaffected by chemical or biological processes. I disagree with that, but because of this, listen, it says, however, enzymes dramatically accelerate the rate of chemical reactions. Well, that's because they're chopping them up and breaking them apart. For example, without enzymatic catalysts, which are the enzymes produced by bacteria, certain biological chemical reactions essential to life would occur at imperceptibly slow rates. They just wouldn't be forever. One study highlighted a reaction critical for life would take 2.3 billion years to occur without the presence of a specific enzyme. And that specific enzyme makes that particular essential process happen in less than 1 second instead of 2.3 billion years. I don't think I could wait around 2.3 billion years to get that extra particle. And the key is, if you understand enzymes, you would fall over dead instantly almost. Literally, within a couple of minutes you die if you didn't have enzymes in your body. And enzymes are actually created by bacteria. Hold on 1 second. This is just starting to get studied. Enzymes produced by gut bacteria. Human gut microbiome comprises trillions of microorganisms, and there's hundreds of thousands of different species that contribute significantly to our physiological processes. These bacteria produce enzymes. Enzymes break down complex carbohydrates and dietary fiber that human enzymes cannot digest. You just can't. The production of short-chain fatty acids beneficial for our colon health. You have to have these bacteria in order to be healthy. All right, this is really nothing you have to even know at all. The only reason I'm showing you this is because I'm going to make a lot of statements that go contrary to physics, the speed of light, energy, magnetism, subatomic particles, bonding, everything. And I also have the new model, which is a dipole electron flood theory. And this now is the proton. It's not just a couple of little particles floating around a big, heavy, positive core. However, it is a big, heavy, positive core. And it literally is dark matter. All of this stuff I can show, and I literally can prove it. Because we started with light. We didn't have to start with the huge particles and dig through all the debris. I showed you that before. And the reason I have to show you this in such great detail about these particles is because every single thing there is based on these particles being what I say they are. Otherwise, none of these materials would happen. You would not have these things. It just wouldn't work. Plus, your body chemistry wouldn't work. Your enzymes wouldn't work. Nothing would work. Photosynthesis wouldn't work. Breathing wouldn't work. Nothing works in the current chemical model, which is the standard model. This is what does work, right here. And the only two particles that exist are these two particles. That's it. There is nothing else. This one is light and energy and static and electricity, lightning, ionization. It's just a glowy little hot particle with no mass. This is the stuff you put in a battery after you, like a car, you fill up with this. When you charge it up, the car gains zero weight. Nothing. Nothing they can see. You know, so maybe they claim it could be somewhere in the nanogram amount. You know, that's billionths of a gram. To charge your car to go drive 500 miles. You put 10 gallons of gas in your car, and you just added 60 pounds, 60. That's because you're adding something totally different than just raw energy. That's just raw energy. There's no weight to it whatsoever. But the two of them together they weigh 0.000585 and some change atomic mass units, which means 1,839 of them together would make one what they call a proton. And this is a proton in my world of 1,839 particles. The black in the center, in their world, it's something like this, that they don't know what's here, and they can smash it to bits and find all the parts I can show you here. But I don't have to smash them. I can show you them in their aggregate, in their little bits and pieces, which are here. I can show them separated, which is the smallest anything will ever get. I can show them together, which is heat. All right, that's a dipole electron, and it's heat. It's not electricity. Electricity is just this one. The static electricity. And it wants to find one of these, or if it wants to find ground. Ground is saturated with these because this has no mass. No mass. You just go like that. It's not even there. This one you go boom, 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 and you're not going to get through that. That is mass. We are made of mass. We're made of dark matter. This is energy. We give off energy, we use energy, but it is not mass. It has no mass. So everything there is that's of a substance is dark matter. That's just a fact. There's all kind of changes to chemistry and the redshift and space-time distance, all that stuff. Or everything that they've been thinking, the stuff coming through space slows down. So, like I said, I'm going to make a hell of a lot of claims that completely change what you have heard in anywhere about anything. Because literally almost nothing that you have heard is true. Almost nothing. And I'll debate anybody about this, and that's what I want. I want some experts. I want some physicists, I want some biologists, geologists, archaeologists, anthropologists, anatomists, chemists. I want them all. And we'll talk and we'll discuss this. And I want somebody with subatomic, expertise that's from the particle colliders to engage. I want this, and we need this. And once this is done and out of the way, and I'm either proven wrong, or it's likely that I'm right, or proven right, whatever it is. And I think I can prove I'm right just with the experiments that have been done. Showing that light can be accelerated quite easily through a Venturi. No added energy required to accelerate that light, creating electron showers and separating the particles. It started like this just as it started to accelerate. And it's a particle creating a wave because the particle itself is very tiny and it's coming through the air with a field around it like a balloon. But you don't see the balloon. It's just there. And that balloon has to push everybody else's little tiny balloons out of the way. So the little tiny balloons, which are electrons that are attached to other particles in the air, get a little bit of glow and they just get out of the way. And this, all right, and then as it accelerates towards the Venturi, it takes off like a Z-rocket ship. Exactly what it does, just like a jet fighter going through the air. It's breaking the speed of sound, which everything is just a speed. Vibration is nothing more than like this. That's slow light. I'm serious. It's just going slow. This vibration is very slow. Up here you got very, very intense light. Down here you got almost nothing, just barely moving. And done. And that's how it works. And this is on the slow end, basically. Now, green is a little faster than this. Same particle. All right, these are the particles they found at Fermilab and CERN, which are the same particles. There's no difference whatsoever. And they do exactly what they said, all the weight. And fixed particles never gets bigger, never gets smaller. It doesn't emit, it doesn't absorb, and it doesn't reflect. And it has a glowy edge around it, and has all the mass, and that's the point particle. This is a picture right from Fermilab. It's exactly what their claims are. No mass, all the mass. Fixed, can get big, can get small. As you can see, bigger and smaller. Bigger means it's concussing. Smaller means it's, because this is going this way. So this is dissipating because it's not hitting. This one hitting stuff in front of it. You probably can't see this, but those are the little particles this thing is whacking into, and it grows its energy field, and then it goes flip, and it flips, and here it is hitting at the Venturi, separating the black from the white. The only reason we can see that black is because it's sitting on top of the white. Black has no ability to do anything other than suck white into it, but it will obstruct the white from hitting us. That's the reason. That's the only reason. That's dark matter. That's the only time you ever see it, is if it's on top of the white. They start out with the muon electron neutrino, the black and white together, and then when they go into the heavy water, they can split. Muon goes on its own, electron showers. That's it right there, and that's in the actual atmosphere. All right, no special anything, just going through a Venturi with laser light, pulsed red laser, and it happened with the green too and the blue. All right, here it is coming in, accelerating. Looking into this is the Higgs fields coming out at us. Those are the Higgs fields they're always talking about. This is a particle nobody in history has ever seen before. I'm the only one that's ever seen it. I've only seen it once. These are the light particles. Those are the photons. That's a downspin. That's an upspin. And they charge up as they go. Flip, flip, flip. These are neutrinos. They're not fully charged. This is a better shot. This is now entering towards the Venturi, directly in line. It's starting to accelerate here and gain energy. All right, and then they turn sideways for a second, and then this directly straight in line it displays as a full-fledged photon. You only get this when it feels like it just hit a wall. And it feels like it hit a wall because of the backwards concussion. That's why you're seeing the photons way out here in Never Never Land. Not supposed to be there. They're supposed to be only when they hit and bounce. And that's my opinion. But when you're way out here, you see it? That's when it starts to show up as an actual photon because it thinks it hit a wall, just like these do. These think they just hit a wall and are going to bounce back. Exactly what I'm saying. And this is the same thing. That's why we see it as a photon. These were in the air, just like this one is, but only this one was accelerating. So it's visible. And then it explodes just like these did because it's being whacked back. These are making just like they hit a wall. And when they hit the wall, in here they don't do anything. This one is because it's plowing through everybody in front of it. But when this reverse, what they call reverse EMF, these big fields coming backwards, everybody here surrounding this thing feels like it just hit a wall. And then, just like it would do if it hit a wall, it will bounce back. And that's what we're seeing there. That is what we're seeing there, my friends. And that over to the other side over here. You see those lines going backwards? Could be a lot of dust there too. No, I guess that's inside. Wow, I didn't realize that. Very interesting. Yes, yes, yes. What are we seeing, my friends? We're seeing the reverse, what's called reverse EMF, electromotive force. Now, what are we seeing where, this is what research is all about. That each one of these lines is a reverse pulsation of an explosion that's happening at the Venturi. All right, this explosion is going like this, but it's going really fast. And this is a subatomic nuclear explosion. This is the division from the black and the white, and the reverse concussion is just stunningly huge. Now, I showed you these reverse waves. Right on the wave line, I'm seeing that it's hitting something different. The further we go, we're seeing something different. Let's start where we can see the waves and how they're interacting because they keep spreading out, spreading out, spreading out. That's the whole nature of electromagnetic wave formation, is it's tighter, 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 and then it just peters out. And I could show you that in space as well. Well, I guess it's actually not the major shocker du jour. I thought it was, but I do know that we're having acceleration, explosion, and then as it slams in, it bounces back. And it's bouncing back at an absolutely incredible amount of speed, like a stone wall back and all the way back to here. Now, this is what just struck me as very interesting. You see all those little lines? Every one of those is a reverse electromagnetic field. Now, in each one of those lines, you see several little white spots here and there, but they're always right on the line. All right, they're not anywhere other than right on the line. Now over here, you can see them, they're still on the lines, but then when you get down into here, it's just buzzed. It's totally buzzed. When you get forward, you get until it accelerates. And then here you can see them here and there. Well, they're pretty much everywhere. But they're not in those lines. They're interacting with all the particles are here. And every one of them is glowing, is just being excited by this reverse wave. Now, why would they be so obvious here? Well, now it makes sense to me. It's obvious right here. You can see there's a black zone here and a black zone there. If you take your time, think about it slowly, that wave is contracting and pulling itself away from the dark matter into a very, very condensed particle beam, which is both the black and the white here. There is no separation until we hit about here. And then they start to separate, and here they're completely separated. And the black is totally separated from the white. The white goes through, comes out on the other side as Higgs fields, and interacts with the dark particles, which is the dark matter on the other side, and recombines and goes back into light again. It goes in with a wave, and it comes out with a wave. Because coming out here, there's nothing more than these same things that went in here. Only they had separated here. And if we can harvest it right there, then I think we got something we can work with. All right, light spins in a circle like this. It doesn't flap like a wave like that. All right, so these are interference patterns, but because they hate each other, the white ones, they push each other and they create their own little lines. That has nothing to do with flapping waves going this way and that way and so forth. All right, they don't go this way and that way. They go spinning in a circle like that. All right, so now that you got the basic chemistry down and you got the little particles down, everything is made of the same particles. And there are thousands and thousands and thousands more than they ever expected. One proton, and the hydrogen is one proton, is not one, it's 1840. And every single neutron and every single proton is approximately 1840. So when you get up into the 90s and the hundreds, you got hundreds of thousands. And that gives you all those different half-lives. They really have no clue about that. They can see some of them, but where is it? But look at all the half-lives they have. And every one of them is a different weight. You see this? This is the mass. The mass is the weight, and one proton weighs approximately, it's called 1 atomic mass unit. In dipole electrons, that's 1840 approximately, is 1 atomic mass unit. So they're going up from 29 to 30 to 31 to 32, 33. Every one of these is one more atomic mass unit. A neutron, it's about 1840, and they're just jumping. All of those are still selenium. And then when they degrade downwards, they go down to arsenic, and some of them stay selenium, germanium. All right, so you got selenium here. You got arsenic, germanium, bromine. So now, as they go past stable and they go on the other side of stable, instead of going down to AS, which is arsenic, hold on. I'll tell you, when you know dipole electron flood theory, you know that this is not possible with the standard model. It's impossible to do this kind of chemistry. It doesn't work. Isotopes don't work. Basically, with the standard model, they just don't work. And these are decaying selenium. You see, arsenic. Then what's this? Br. Why is that? Why is that? It went up. Instead of going down to arsenic, it's going up. That's because it's got too many particles, and it becomes stable when it goes up to bromine, to Kr, krypton, all right, which is a stable particle supposedly, and bromine ought to go all the way up. And the same thing happens with sulfur. Sulfur and phosphates is where your membranes are. And, well, that's a whole other issue. But anyway, they all have that. They all have the same thing, a zillion different half-lives. And the enzymes can work and do the chemistry within less than a second that would take 1 billion years to do. So that's how they work with all these little particles. But there's not just 32, then it goes to 33, then it goes to 34. No, it goes to 32.000010000020003. It's a bazillion particles between every single one of these, what they consider to be semi-stable states, half-lives. All right, so I know I probably confused you, but this is not hard. It's very simple. Stay with me on this stuff. Don't run and hide from it, because you're going to be the first people that are trained on the new dipole electron flood theory. If you don't know this, you don't know chemistry. You don't know chemistry, you don't know physics. You don't know biology. You don't know matter. You don't know anything. If you don't start from the beginning and understanding this, you're never going to get anywhere. And then once you do understand this, you understand how things interact with each other and how energy comes out of the sky as lightning and static and electricity, and how desperately this particle that has no weight whatsoever comes to find this particle, and it moves electric motors, and it will even go through your body and explode you to get to that. That's how desperately that white wants to be attached to the black, which is all the mass, it has all the weight, and this has no weight whatsoever. But when it gets dragged over here, it does work. It will power your car, it will run lights and anything, whatever, it has to get to there, just to try to get to there. Pushes anything through, it is in the way, out of the way. And exactly what I showed you here with that red photon pushing everybody out of the way. Get the hell out of the way, and zip. And then there's the blue. The blue is just too fast to even work with. Just zip, it's gone. And you don't even know it's two particles until it spreads out way down here, slows down. But you can see it's spinning. That's all one particle. You take a picture and you get all these shots at the same time. And so is this one. And this is a downspin. I mean, that's the upspin. And that's a downspin. They're always polar to the Earth, up and down. Although we have spun them in a barrel roll by putting both of them at the same time through the same venturi. The green pushes the red right out of the way. It just hits the white and just makes it go circles like that. Why don't I show you? You sure? All right, you saw the white was sticking up and spinning this way. Well, this came through and hit that white and made them tumble. You see them tumbling? That, and then the green reconcusses way out there. It's just pushing the white, the red right out of its way and makes it tumble. That is not normal. They normally spin polarized to the Earth, called up and down spin. And you see how much more powerful the green is. I don't think they're traveling at the same speed. I think white light, with all of these together at the same time, travels at a certain speed. But I think red goes slower than the green and impacts quicker and slows down faster. And they all slow down. So don't tell me light doesn't slow down. And there is no vacuum in space, as you can see right here. There's no vacuum out there. This is just 100% particles. All light particles are out there, but light comes from the sun, is everywhere. From every luminous body creates light. And these are magnetic fields, as whatever it is spinning through space. And I now understand how these magnetic fields are formed. They're not formed from iron cores or anything. They're formed from the concussion of the size of the body as it spins, creating a capacitive discharge. Capacitance is discharge. Capacitance, that's what this is. And light going through this does not travel at the speed of light. There is no speed of light. Light goes at all kinds of different speeds. And whatever's in front of it is going to slow it down. And these are slowing down. And this Webb telescope saying we're a bazillion trillion miles and everything's spinning out of the way from us so fast. No, that is not correct. The light is slowing down coming to us. It might be expanding, I don't know, but that is not necessarily why we're getting the red shift of the light coming at us. It's coming and hitting and slowing and slowing and slowing and slowing and slowing. And eventually it becomes what's called a cosmic microwave background, where it's just not even moving anymore. It's just laying around out there, basically. And then you get this, what I just showed you. is this here, which sort of shocked me a little bit. Well, it didn't shock me, because I know this would happen, but it's nice to be able to visualize it. Actually seeing those particle lines interacting with the actual particles of light. Because one of them is a light, and one of them is a particle. Well, light is particles too, but they're moving fast. And that's what's making all these little dots glow. And you can see it actually better in this one. This one's got a little closer up on it. And these are all gases and probably in the air. I mean, gases, dust, whatever. And this is the particle speeding up, starting to really accelerate towards the Venturi. This is the tip of the spear, so to speak. And the particle is tiny, tiny, but it has a huge magnetic field. Just like every magnet, you push them close together and they want to repel, you go boom, 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 boom. You don't see anything, there's nothing there, but a boom, boom, boom. And if they want to attract, snap, they pull in together. And those are concussions of field reactions. And there's a ton of it here. And out here, they're still reacting because everybody's got to move out of their way in space. This is a whole new field. This is a whole new field now. Okay, my outstanding friends. Today is going to be an extremely interesting day. I do extremely long videos. And I have to do them long because they are more involved than just to look at this and have a nice day. People say, oh, you got to make 3-minute videos. Nobody ever watches more than 3 minutes. Well, I don't care about those people. I don't get a whole lot of hits. That's okay. The ones that I do, I hope, are learning something. Now, today I'm going to give you the physics and the chemistry and all that behind literally everything in your life. Everything in your life. Not just about mud fossils, not just about light, not just about God. Because this is going to be about God. And it's going to start off with light. And I'm going to show you the research that was done on this light by Rod Warren in Australia. And he was looking for something within the light, and I believe he had found it. I'm not sure. You'll have to make your own determination. But Jesus Christ himself said, we are made of light. And he said a lot more about light. Listen to this. Okay, so is science and religion and God and Christ and all that stuff separate? And no, it's not. They're exactly the same thing. Jesus Christ, if this is him, I don't know. That's light. I see no reason whatsoever from the research I have done to expect this looking like Jesus Christ and looking like some kind of demon with flared horns or something coming out of his head, screaming at Jesus. Now, that is light. All right, Jesus said he is light. And it says hundreds of times, literally hundreds of times in the Gnostic texts about Jesus and how there was no words to describe the light that was about him. You couldn't see him for the light. And finally, the disciples said, please, Jesus, withdraw your light so that we may see you. And he did, and then they saw him. But he was looking like this, and they just like looking into the sun. And then all of a sudden, he let himself go. Look at this. I don't know if Rod found anything or not, but boy, I'll tell you, I've seen some of the ancient paintings that look just like this, people screaming from... Okay, my friends, I'm just going to blurt it out. As far as I'm concerned, Jesus said he is light. He's made out of light, and so did the disciples. And they said it was always you couldn't see him because there was so much light. Okay. I study light, and I study it as deeply as anybody that's ever breathed oxygen. Trust me, I have seen more light than anybody ever from the research I did with Rod Warren, who took these pictures using light acceleration. Now, look at what you're seeing here. Jesus Christ said, I am light. I am made out of light. Basically exactly what he said. Now, again, I understand light. And I understand when light gets brighter, it's impacting something of substance. Light just does not manifest itself until it interacts with something of substance here on, because there's light all over the place here. You don't see that light until it hits something. You see that? That's bright. Why is that bright? That, to me, this is a 3D image of something. And it's wrapped around, and even if that's the nose, it's a little bit brighter there. That's the cheek, it's bright. This is exactly identical to the structures of a human face, which to me represents something that damn near looks like it could be Jesus Christ. He said he was the light. I mean, there is nothing here that does not conform. Now, what is this guy? If this is a creature, he has exactly the same things with just a face, and look, it's like it's spewing out something here. It's a vapor. All right, you see the difference between this and the rest of this stuff? And what's this, these things trailing off, sticking off out of his head, it looks like to me? I don't know. Again, this is just speculation of the most extreme time. Oh, the guy's got PhDolia. I call it PhDolia because they can't see what's in front of their faces. And they can't read what's been written because it's not allowed in those areas where they don't think science and religion can work. There is no science. It's only made from religion because religion starts with the Creator. I study all the ancient texts, not just the Bible, not just the Nag Hammadi, not just the ancient texts, Apollodorus, Ovid, and all those. They were closest to the source. But the Nag Hammadi text, just discovered in 1945, had been underground for 2,000 years. Nobody's screwed around with them. They were written at the time of Jesus and stored and hidden because they know they were going to be destroyed. And they said they were going to be unveiled. There is nothing hidden that will not be disclosed at the end of time. And I'm going to tell you right now, a lot of things being disclosed. Jesus said, I am the light that is over all things. I am all. From me all came forth, and to me all attained. Split a piece of wood, I am there. Lift up the stone, and you will find me there. That's Jesus Christ talking about light, being light. I am the light. Now listen to this one. I think it's 60. No. 50. I think it's 50. Yeah, here it is right here. Jesus said, if they say to you, where have you come from? He's talking to his disciples. Say to them, we have come from the light, from the place where the light came into being by itself, established itself, and appeared in their image. If they say to you, is it you? Say, we are its children. We are the children of the light. And we are the chosen particles of light to be alive by the living Father. If they ask you, what is the evidence of your Father in you? Say to them, it is motion and rest. Energy and not energy, still the same particle. Light is everything. So it's everything, and it's just sitting there doing nothing. Motion and rest. Now look at this, listen, 56. Jesus said, whoever has come to know the world has discovered a carcass. And whoever has discovered a carcass of that person, the world is not worthy. He's talking about the world, whether that's the creatures in the world, the humans, which is also basically all carcasses walking around with no mentality whatsoever at this point. And I'm just serious, that's just a fact. They've been menticide into believing things that Jesus Christ said, this is what's going to happen. You're going to have false teachers. And they will concoct stories to use you. And that's exactly what has happened. Exactly.